All right, hey honors chemistry. So now here I'm going to do an example of a problem that is going to be limiting reactant, and I have to figure out how much product I'm making from two reactant amounts. So let's look at this question. It says 1.50 moles of aluminum reacts with 0.072 moles of iodine to form aluminum iodide. How many moles of the excess reactant will remain? How many moles of the aluminum iodide will form? This is going to be a limiting reactant problem. I have two amounts now. Usually I've only given you one amount, or I've given you an amount and then a yield, like an actual yield. But I have two amounts for my two reactants. This means I'm going to have a limiting reactant problem. Okay? And I'm going to ask this question on a future quiz. Like, how do I know I have a limiting reactant problem? I give you both amounts of reactants. All right, now before we start doing any calculations, let's see if we could try and write the balanced chemical equation. It says when 0.5 moles of aluminum reacts with iodine or iodine. So aluminum is Al, and iodine, if you remember Hofbrinkel, iodine is I2, to form aluminum iodide. So remember, I said take a breath, pause. How do I write a formula between aluminum and iodide? Well, if you look on the periodic table, which you should do that, aluminum and iodide, this is going to be an ionic compound. How do I know it's ionic? I have a metal and nonmetal, just as a quick review. And then I don't have any prefixes in here, like mono, di, tri, so I know I have an ionic compound. So because I have an ionic compound, I have to worry about their charges. So aluminum is Al3 plus. Iodide or iodine by itself will form a charge of -1. If I do the crisscross method, or if I figure out my way of writing my formula, I should have the formula Ali3. Right? And I'm putting the dashes on top so I know that's an I. And then if I want to balance this, convince yourself that this is how you balance this. I put a 2 here, I put a 3 here, and then I put a 2 here. Okay, it is balanced. I have two aluminums, 6 I's, and I'm done. Now, I'm going to try and put the lines in and do my BCA table now. It says 0.5 moles of aluminum, so that's going to go here. Reacts with 0.72 moles of iodine. So I'm putting those amounts that they gave me now both in my before section. Now I'm not writing the word XX. I'm going to have an excess, but I'm going to have a number instead of just writing the letters excess. And then I know I have 0 products to begin. All right. Now the method that I like to use is by putting 2 dashes here and figuring out how many moles of my product each of my reactant gives me. Okay, so I'm going to put this here. This is going to be from Al. This one's going to be from I2. Now, just by looking at this, if I'm using all of my moles of aluminum and I'm ignoring my iodine, right? This is just a procedure. This is how I do the calculation. If I'm using all of my moles of aluminum, my 0.5 moles of aluminum, it's a 2-to-2 ratio. I should get 0.5 moles of aluminum iodide just using the aluminum, right? So the procedure I'm doing is figuring out how many moles each of my reactants give me for product. So if I'm just using my aluminum should give me 0.50 moles. If I'm using just iodine, I'm going to do the dimensional analysis way. 0.72 moles of iodine times 2 moles of aluminum iodide over 3 moles of iodine, right? So I always put want over have. I want my moles of aluminum iodide, and I have my moles of iodine. This 2-to-3 ratio comes from here. Or you could use Kirsten's way, where you're going to divide by 3, multiply by 2. If I do this correctly, I should get 0.04, sorry, 0.4 0.48 moles, if I do this correctly, right? And I'll check that on a calculator. I remember doing it earlier. So 0.72 times 2, right? So we do times 2 divided by 3, and I get 0.48. So I got 0.48 moles and 0.50 moles. As mentioned in my notes, I always choose my lowest moles of product that are formed. So I'm choosing 0.48 moles of iodine. That's how much product is forming. I choose my lowest moles. That is the procedure for us. Okay? And so because I'm using this, I'm not going to make 0.5. That's too much. One of my reactants is limiting how much I could make. I'm only going to be able to make 0.48 moles of AlI3. And that's one of our questions, is how many moles of aluminum iodide will form? 0.48 moles of AlI3. And if the question asked for grams, I would just multiply by the molar mass of AlI3. Now I could work backwards now to figure out how much aluminum I'm using and how much iodine I'm using, right? So now that I'm not using this, if I am making 0.48 moles of aluminum iodide, my aluminum to aluminum iodide is a 2 to 2 ratio, which is the same as 1 to 1. So I should be using the same amount. If I am making 0.48 moles of aluminum iodide, I should only be using 0.48 moles of aluminum. And then I'm going to have 0.02 moles excess left over. And that was one of the questions. It says, how much moles of the excess reactant will remain? Well, I'm going to have 0.02 moles of this left over, and we're going to see how I'm using this completely. If I'm making 0.48 moles of I2 to work backwards, if I have 0.48 moles of I2, and you're going to see I got this from I2, so it's going to be 0.72. There are 3 moles of I2 for every 2 moles. Sorry, this is AlI3, my bad. This is AlI3. For every 2 moles of AlI3, if I do this math, 0.48 times 3 divided by 2, I get 0.72 moles of I2 is used up. And that's actually how much I have. So minus 0.72 moles, and I have 0 left over. This is what I call my limiting reactant. It gets used up completely. It actually determines which one gives me my lowest moles of product. My lowest moles, my 0.48, came from I2. So this is my I2 limits the amount of product. And because of that, I can answer, just to answer the other question, how many moles of the excess is there? Well, I know that aluminum is in excess because I'm only using 0.48 and I have 0.5. So I'm going to have 0.02 moles left over. Okay, so this is the in general procedure on how to answer a limiting reactant question. I'm going to do moles of both my reactants to my product, and I choose my lowest moles. I'm going to do another, or the rest of the examples, and it's up to you to make sure that you follow this procedure in order to be able to answer limiting reactant questions.